Okay, so for this video, we are going to discuss how to solve the equation of inequality with indices. All right, so indices means that when you are having some power with x, all right, and then usually when you are having indices equation, then generally we need to use log. Okay, you can take natural log or log, or maybe log base 10 if you want, okay, on both sides to solve the equation. Okay, so before we discuss the question, right, generally before you solve the question, you need some basic knowledge on indices. Right, so I actually attached the property of indices here, and all these property actually we learned it before in chapter 0 before you start your AS lesson. All right, so just a very quick revision. So you need to know what is multiplication rule. That means when you're having the same base number but with different power and you multiply each of them together, then you actually can do it by adding the power together. And then for division rule is when you want to divide it two same base number with different power, then you can actually just combine them, become base number A power n minus n. Then power on power rule means that you multiply the power together when you're having the power and outside the bracket got another power. So you multiply the power together. So this is what you call as power on power rule. And after that, we are having the factor rule. So for factor rule means that when you're having a bracket with a power outside, you can actually multiply in the power to both the numbers. Okay, so all this property, all this rule here, actually you learned it before. So we are not going into discuss in detail anymore for all the rule here. Okay, but generally for all the equation and inequality that involve indices, we actually need to rephrase our equation by using all these properties. All right. Okay, so maybe we can discuss our example 7 now. So all these example, some of them I take it out from the past year question as well, but I forget which one already. But generally, you can see they are all these questions, they are having power with x. All right, so they are having power with x. And then to solve all this kind of equation, right? Generally, I will tell students, I will actually separate it into a few patterns. All right, so the first pattern is from A until E. Okay, so A until E I call it as first pattern. The second pattern starts from part F until I. Okay, and then J until M I put it in another pattern. I include as another pattern. So generally you're having 3 patterns here. And then when you want to solve all these patterns of question, right, you can have some, how to say, I will actually separate it into 3 different types of question because there are some guidelines for you to solve it. Okay, different type of question, then you have some slightly different guidelines. All right. Okay, so have a look. What's the difference for all these 3 parts? These 3 patterns here. Okay, so for the first pattern here, you will see that in the equation, there's no sign. I mean, okay, so maybe you compare pattern number 1 with pattern number 2. When you look at pattern number 2, you're having something like this, something plus 3, and then something minus something, minus and plus, and then plus. So this one I call as pattern number 2. And pattern number 1, there's no plus and minus sign like this. Can you see that? They are all multiply. Multiply, then bracket, multiply with another bracket. This one is multiply, not dot. All these are multiply. Okay, so pattern number 1 mainly involve multiplication and also division. Then the second pattern mainly involve the plus and minus sign. Right, and the third pattern, I put all the modulus function and also inequality under the same patterns. All right, so there are 3 patterns here in total. Okay, so I'll discuss pattern by pattern. All right. Okay, so now let's have a look for pattern number 1. Okay, so for pattern number 1, when your equation mainly are having only all the multiplication and also division, generally, right, before you solve the equation, I will suggest you all to rephrase your equation to become a number with power x equals to a number. Okay, I will suggest students to rephrase your equation or your equation into this pattern first. That means all the power x, you put it on the left with a number, and that equals to a number on the right hand side. Then after that, it will be much more easier for you to solve. Okay, so of course this is not the only method, but to me, right, if let's say you try to rephrase the equation like this, then later when you solve it, to me it will be much more easier. Alright, so as an example, maybe I will show you one. For this question, for this one, maybe I will solve part 1 and also part B, A and B. Then you try C, D, E yourself later. Okay, alright, so what is the meaning of this one? A bracket, a number with power x equals to a number. Okay, so maybe we have a look for part A. I'm having 2 power x plus 1 equals to 3 power x. So some students, they will tell me they will take log both sides straight away. Okay, your method is not wrong. But to me, if I want to make my calculation easier, usually I will group all the x power together. But before that, I'm having a problem with this. I'm having power x plus 1. So actually power x plus 1, you can split it become 2 power x multiplied with 2 power 1. Right? Because 2 power x, a power m multiplied with a power n is actually equals to a power m plus n. Correct or not? So this is, I do it in the opposite way. I separate it. That equals to 3 power x. Okay, so when you rewrite it like this, right, you can actually have a look and you can group all the terms with power x together on the left hand side. So I move the 3 power x over, become divided, and then the 2 power 1, you bring it over, it will become 1 over 2. Okay, and after that, for this left hand side, because both numbers are having the same power, therefore I can apply the factor rule. That means that you can take out the power x out from the 2 and 3, and which is equals to 1 over 2. So if you look at this pattern, generally you will see that it is actually what I suggest you just now. So we are having a number with power x equals to some number on the right hand side. Okay, and then once you group your x like this already, then only I will take the ln. I will take ln both sides, so I'm having ln 2 over 3 power x equals to ln, and then the whole thing is 1 over 2. Okay, and then the power x here, you can actually put it in front, right? And you're having x ln 2 over 3 equals to ln 1 over 2. And to get the value of x, you are taking ln 1 over 2 divided by ln 2 over 3. And pressing calculator, try to get the answer 1.71. Okay, so this is how I do it. And then some students, they said, I will take ln from the beginning. There's no problem. All right, but for me, I realized that if I rephrase everything like this, then only I take ln, sometimes it will be much more easier. Okay, all right, so this is what I suggest. It is just a suggestion, all right? So if you have the idea how to do it, you can follow your steps yourself. But for those who are like, no idea how to do it, this is what I suggest you. You try to imagine how to change your equation become something like this, then only you take the ln both sides. That is easier for you. All right, okay, so this is how we solve it. And then before I proceed to the next part, right, there's one common mistake that student will do here. When you bring the ln over, okay, it is not ln 1 over 2 divided by 2 over 3. This is wrong. Okay, this is correct and this is wrong. But a lot of students will do this one. Alright, so please take note and make sure that you don't do this kind of careless mistake. Okay, you have both ln now. On top of ln, bottom also have ln. You cannot just combine them become a ln here. Okay, alright, so take note of this. It's a very, very common mistake. Okay, alright, so now if let's say you roughly have an idea how to, I will show you again part number B. Then you try the rest of the part yourself. So now I'm having part B here. I'm having 7 power x plus 1 equals to 2 power 3x minus 2. Right, so again, for all the power with plus or minus, I will just try to rewrite again, it will become 7 power x multiplied with 7 power 1 equals to 2 power 3x multiplied with 2 power negative 2, right? So 2 power negative 2, I can actually write it become 1 over 4. Okay, so why I get 1 over 4? It is because of 2 power negative 2. Okay, then now let us talk about 2 power 3x. The 2 power 3x, I can actually write it become 2 power 3 and then multiply with x. This is the power on power rule. And also, if you try to expand 2 power 3, so 2 power 3 will be 8. And eventually, you have 8 power x. So this part, I'm having 8 power x. Then multiply with 1 over 4. Alright, then if I try to rephrase everything, all the terms with power x, I will move it to one side. And then all the pure number, I will move it to the other side. And I'm having this 8 over 7 power x equals to 28. So again, you will see that I rephrase it into this pattern. Then from here, only I start to take ln for both sides. So I'm having x ln 8 over 7 equals to ln 28. And x equals to ln 28 divided by ln 8 over 7. So again, by pressing the calculator, you should be able to get the answer, which is 25.0 into 3 significant figures. Okay, so of course, when you want to solve all this, right, you have to be quite familiar with the indices rule before you can take the ln. Alright, so all this you need practice because all the knowledge here you learned it before, just that we seldom apply it. And now you are going to apply it quite often by solving all these kind of equations. Okay, so this is what we have for part A and part B, and you will see that before I take ln for both sides, I'm actually rephrasing it into this part, this kind of equation. Then only I take the ln from both sides. Yeah, right. So if no problem, then I will just keep C, D, and E for you to try out yourself. I will just show you, give you the final answer here. All right, so the final answer C. Okay, so for part C, you should get an answer 3.50. Answer for part D, you should get 3.38. And the answer for part E, you should get 0.640. Okay, so these are the answers for C, D, and E. You try on your own. If you cannot get an answer, please let me know, or you can discuss it with your friend. Okay, but make sure you try it. Don't just copy the solution from your friend. All right. Okay, then you proceed further to the second pattern. Okay, so for the second pattern, as I mentioned just now, you will see that in the equation, they are having either plus or minus in the equation. Okay, so usually for this kind of question, it's actually can be the linear equation. It is actually in the pattern of linear equation. It can be also in quadratic equation. It can be also in cubic or quartic equation. Just that I don't know whether you can see it or not. And therefore, usually I will tell students, if let's say when you're having this second kind of pattern of, usually you can let y equals to something power x. Or maybe you can let y equals to something power 2x or 3x or whatsoever. It depends on the style of the question. Okay, right. So this is just a guideline to guide you. Okay. So maybe again, I will solve the equation for you, some question for you, and then you can try to solve the other one yourself. All right. So for me, maybe I will show you part F and also part H. Then you solve G and I yourself. All right, so let me start with part F. So for part F, I'm having 3 power 2x plus 1 equals to 3 power 2x plus 3. Okay, so again, I don't want all the power be plus or minus 5. So I will just separate them first. It will become 3 power 2x multiplied with 3 power 1 equals to 3 power 2x plus 3. Okay, so if I look at this equation, I realize that in my equation here, I'm having two similar terms, which is 3 power 2x. Can see that not? Both are 3 2x and these two are the same thing. Alright, so if you want to make your steps look easier to understand, you can let y equals to 3 power 2x. Since they are the same, so you just let y equals to 3 power 2x. So if you substitute this one as a y, so y multiplied with 3, you have 3y equals to 3 power 2x is a y, so y plus 3. Can you see that you will have a linear equation now if you substitute the y correctly? Okay, and then you're having 2y here, so 2y equals to 3, y equals to 3 over 2. And now, this is not your final answer because your final answer should be in terms of x, is in x, not the value for y. Therefore, you need to change it again. What is your y just now? 3 power 2x, and it is equals to 3 over 2. So again, you see that this is actually the I show you in the first pattern, something with power x equals to a number on the right hand side. Therefore, you can take ln both sides. So when you want to take the ln both sides, it will become 2x ln 3 equals to ln 3 over 2. And after that, you try to bring everything over to get the value of x. So 3 over 2 divided by 2 ln 3. Okay, so the 2 here, you cannot multiply it into the 3, it is wrong. 2 is outside the ln, so you cannot mix them together inside the ln. So after you press calculator on this, then generally you will get an answer which is 0.6. Sorry. This is one and this is part F, right? Okay, so you should get 0.185. Okay, so this is how you solve it lah. So some students ask me actually, if let's say I don't want y equals to 3 power 2x kind of all, because they can see the pattern clearly. If you can see the pattern clearly, then you just go ahead, no need to substitute it. But if let's say you cannot see the pattern clearly, then I will suggest you to substitute it. Then you can see the pattern very easily. The equation become very simple, and after that you can solve it. But you have to make sure that you change it back, become the x to get the value of x. So this is 0.185. Okay, so we can try another one. Part H. Alright, so how about we have part H here? So for part H, I'm having the equation 5 power 2x minus 5x plus 1 then plus 4 equals to 0. Alright, so again, I will try to split this. Okay, so 5 power 2x, I will just keep it first. Or maybe I will try to write it become 5x power 2, like this. Minus 5x multiplied with 5 power 1 plus 4 equals to 0. So if let's say in this equation, you will see that I'm having 5 power 2x and 5 power x. So power x is in the smaller unit, right? Power x. Then this is power 2x. 2x is larger, x is smaller. Therefore, if I want to substitute y, right? So I will let y equals to the smaller power 1. I will let y equals to 5 power x. Like just now, both power are the same, so you just let y equals to 3 power 2x. But now you're having two different power, 5 power 2x and also 5 power x. So I will substitute the y become the smaller power 1. So I will let y equals to 5 power x. And then for 5 power 2x, I can rephrase it like this, 5 power x power 2. Therefore, I will have y squared equals to 5y plus 4 equals to 0. So you will see that I actually get a quadratic equation in terms of y. So from here to solve quadratic equation, I factorize it out if you want. And therefore you're having two values of y. Okay, and then of course this is not the final answer. Substitute back, you are having 5 power x equals to 4, 5 x equals to 1, take ln. Okay, so maybe I skip the step a bit here, alright. Okay, so x is equals to ln 4 divided by ln 5. Same thing happened here, x is equals to ln 1 divided by ln 5. Okay, so if you press calculator, you will get the answer for x, which is 0.861, and also x equals to 0. Okay, so you will see that for example part F, after you substitute the y, you get a linear equation. And then for example part H, after you substitute the y, actually you get a quadratic equation. So of course in exam, you might have linear, you can have quadratic, you might have cubic, you also even might have quartic. Alright, so because our syllabus is until power 4, quartic. Okay, so this is how we substitute the equation, the y in the equation, and you get it in an easier formula so that you can solve it in an easier way. Yeah, so this is what you have for part F and H, and therefore please attempt part G and also I yourself. I'll give the answer for part G. Okay, answer for part G should be 0.694, and the answer for part I is 0.481. Okay, so please try these two examples and see whether you can get the answer or not. Alright, they belong to the same pattern as part F and also part H. Alright, so if no problem, then we'll proceed to the third pattern. Okay, so for third pattern, generally I actually group all the modulus function and also the inequality together in the third pattern. Right, so if let's say you're having the modulus function, right, then what you need to do is like, you just need to make sure that you apply the modulus function rule. Okay, like all this, what is this one? This one is modulus function, then you can split it become two parts. One part with negative, one part without negative. Same thing happened here. Alright, okay, and then for inequality, you just solve it normally. And then when you're having modulus with inequality, then you have to apply the rules of the modulus inequality rules. Right, okay, so again, maybe for this one, I will try to solve J and M for you. And then you solve it yourself for K and also L. Okay, so let's start with part J. So for part J, I'm having a modulus form, modulus 4 minus 2 power x equals to 10. So last time when you learned, when you're having a modulus function, right, you can split it become two parts. One part is without reflection, another part with reflection. Without reflection, what is the original one, which is 4 minus 2 power x equals to 10. And then another part is with reflection. So with reflection, it will become negative 4 minus 2x equals to 10. This is with reflection one, right? So some other books, they will straight away put a negative here. But generally, the concepts are the same. Okay, so this is the reflected part. Therefore, I put a negative in front. You have to consider both. Okay, then after that, it's very easy. What you need to do is that you just take, you just try to solve this equation. So you're having 2x equals to negative 6. And for this one, you have 2x equals to 14. Okay? Alright, so after that, how can you solve it? Okay, so if you want to take ln both sides here, you will see that when you take ln both sides and you try to press calculator for ln negative 6, you will see that this is actually math error. Alright, therefore you ignore this whole part, no solution for this part. Okay, and then now you focus on here, and again you take ln both sides, it will become ln 14 divided by ln 2. So you'll get a value for x. So this value for x will be 3.81. which is in 3 significant figures. Okay, so this is what you have for part 0. So again, what are the rules that I apply is the modulus rule. So when I want to split the modulus function into non-modulus form, right? So one function got modulus, another function got no modulus. So this is what you learned before. Oh, sorry, one function got its original function, another function got negative. All right, so this is what you learned in chapter 1 before. I hope that you can do some simple revision if let's say you already forget. Okay, then we continue to part M. Okay, so for part M, I'm having a modulus function, or I should say it's modulus inequality. Okay, so for modulus inequality, there are formulas for you to follow, right? When you're having modulus x, okay, so just to recall back, last time when you learned, when you're having modulus x smaller than a, how can you expand it? It will become the x is between negative a until a, right? Okay, so the same thing happened here. You just expand it by applying the formula for this formula. Okay, so you're having negative half is smaller than 3 power x minus 8, and it is smaller than half. Okay, so now your aim is to change the center part here become x only. So how to change it become x? Every single part here you plus 8, plus 8, plus 8, and plus 8. When you plus 8 for all the 3 parts here, you will get 15 over 2, and then 3 power x, and also 17 over 2. Okay, then now you want to put the x down, right? When you want to put the x down, that means you have to take ln for all the parts. So you're having ln 15 over 2, and then x ln 3, and then ln 17 over 2. Then you try to divide everything here, every part here by ln 3. So divided ln 3, divided ln 3, divided by ln 3. So when you divided every single part here by ln 3, then very easily you will get the value of x, which is 1.83, and then x, and then 1.95. Okay, so this is how we actually solve the equation or inequality that involve modulus or modulus inequality. Right. Okay, so generally you need to apply the modulus rule that you learned before. Okay, all right, and now for part K and also part L. What are the answers for these two? So you try yourself. I will just give you the answer. So for the answer for part K, it is, there are two values here, 0.631 and also negative 0.369. There are two values here. And then for part L, the answer is n greater than 3.15. Okay, so please try to solve and see whether you can get these two answers or not. So again, if let's say you cannot get an answer, either you can discuss it with your friend. Don't copy your solution. Don't copy their solution. Discuss that. Discuss the question. Or if not, then maybe you can come and ask me through Facebook. Alright, so this is what we have for the example with ln function, the ln, and also the example with indices, the equations with indices. Alright, and then for the next video, next video I'm going to discuss for A-level syllabus, right, they can even combine actually the polynomial with indices or ln function. Okay, so we'll discuss it in the next video. But there's only one example, so it will be kinda short.